purpose of this demonstration is to show what the minimum of the sum of the squares actually looks like graphically. In order to do that, we're going to first generate a scatter plot, and we're going to see this correlation. And the correlation coefficient will be published here. So let's go ahead and add in just 3 data values to start with. And we see here that we have a correlation of about 0.62. Now, looking at these 3 dots here, if I were to draw a line through 2 of them, we can see here that the sum of the squares is very, very large. This red portion here represents the minimum. You cannot go any lower than this red portion with your least squares line. The green portion estimates how far over you are from this minimum. And trying to go through these 2 points here, we are very far over the minimum. If I try to go through the other 2, again, I see very similar behavior. I'm not quite getting this line of best fit to minimize the sum of squares. And if you try to go through these 2, we don't have much luck there either. As you can see, we are still not getting this green portion to drop down. So what we've established so far is that when I try to fit a line through only 2 of these points, I am not getting a line that would be considered a good model for this data. So what we have to do is we have to figure out a way to get this green portion to come down and meet this red. So what I will do is I will adjust my line to see if I can get it to go down. And it looks like what I've picked right now is not going to go much further than this. So I still haven't quite got the least squares line, but I am getting closer. If I bring this down a little bit, I'm minimizing those sum of squares, which is what I'm trying to do. Bring this up, trying to get that a little bit lower. I'm not having much luck here. This is about as low as I'm able to get it. So this green line here is representing my guess as to what I think the best line of fit is. Now when we do this mathematically, we see that the red line shown here is the line of best fit based on minimizing that sum of squares. And when I match up my green line with that red line, we can see that I cannot go any lower in the sum of squares than what I have here. This is the line of best fit. And this is what it means when we talk about minimizing the sum of the squares of the residuals.